Hi everybody, Geoscience Joe. Yeah, it's me. I gotta make a quick video because I'm out here on a highway cut. So this is definitely a dangerous spot. But I got my orange on. And none of the kids are with me, obviously. And right here, I believe I'm standing on the boundary of Munchuck and Pottsville Formation right here. You see where the water is coming out of the shale layer. That looks like a shale layer right here. That's why the water is coming out so easy. Well, no, shale would block water, wouldn't it? Nah. Maybe it's very weak sandstone or something. But whatever it is, it looks like this is the boundary right here. See it going down? The beds are still dipping southeast, northwest. And it looks like this is the boundary right here. This looks like all Munchuck. I took sample, it's red shale. Well, all the way down there is red shale. And then I think down here would be the boundary. Here, let's go down here. I'm just up here investigating. I haven't got a chance to actually look at this road cut yet. So, this rock face got two. See this boundary right here going up there? I don't think that's not a bed boundary. That's no, that is a bed boundary. Or no, I think it's a fault. It's a fault. It started out as a bed boundary. Now it's a fault because it doesn't look like it's going the same way. Because see, these are bed angles right here. See that one going up and that one? Those are the beds. So the beds look like they're going 40, 45 degrees-ish. And then I think right here, see it? See how it switches up? I think right here would be the start of the Llewellyn Formation right here. Look at this avalanche waiting to happen. Nice. Looks like all the water broke through a shale layer, then broke through the beds and sent it flying down here. Alright, but I'm going to collect rock samples and examine them. Take it back home for further analysis. Good evening, Geoscience family. Geoscience Joe. Bienvenue à ma maison. Welcome to my crib. We're back from the road cut, and I got the rocks right here, and in stratigraphic order from oldest to youngest. And let's just analyze these rocks. Not too much. Let's just talk about them and just some fun facts. So first here we have a piece of Munchuck Formation. This is red shale because it's not that hard. It would come apart pretty easy. If I smashed it on my floor, it would fall to a bunch of pieces. What's that? Looks like a fossil right there. But anyway, you can see that the color is red, which means that this rock was made from sediments that were oxidizing, which means they were above water. But you see how you can also see some green in there? That means at one time, these sediments got recovered with water, like swamp water that had algae in it, or some type of other bacteria that was used in photosynthesis, and they color rocks, that organism colors rocks green, like siltstone and shales. So, and you can see there's some mica in there. So, these sediments came from rivers. Mica and sandstones and shales means they came from rivers. Fun fact about this, this shale's radioactive. I don't know if you can, but Munchuck shales contain a lot of they contain uranium. Actually, uranium prospectors around Jim Thorpe, they could have mined uranium around Jim Thorpe, which any Pennsylvania knows used to be called Munchuck. That's what this formation is named after. But good thing they didn't mine uranium in Jim Thorpe, because it probably would have destroyed the environment. But that's cool. Like, most people don't think of Pennsylvania as a good spot to mine uranium, but there's actually uranium that could be mined. And then next up here we have conglomerate from the Pottsville Formation. Pottsville Formation is mostly conglomerate. And the reason why there's so much conglomerate in the Pottsville Formation is during the time Munchuk Formation is from like 340 million years ago, about 340 million years ago. And then right here, during the time the Pottsville Formation was being formed, what was known as the Allegheny orogeny was taking place. That was the last orogenic event that made the Appalachian Mountains. So, and conglomerate, you can see there's a whole bunch of different, there's pebbles in there, sand, a whole bunch of particles of different sizes. And conglomerate forming during an orogenic event kind of makes sense, because as the land's uplifting, it's getting steeper, so there's more mass wasting, mudslides, landslides going on. So all these sediments got deposited together. So yeah, that kind of makes sense. And another cool, conglomerates are really cool, and they're actually really rare. Sedimentary rocks as a whole comprise only a quarter of the entire stratigraphic record. That means out of 4.5 billion years of rocks, only a quarter of that is sedimentary rocks. And conglomerates are only 1% of sedimentary rocks. And conglomerates are very good. They have good porosity and permeability. Porosity is like the empty voids that are inside here. You can't see them, but they're in there. And then permeability would be how connected those voids are. So not only does conglomerate have good porosity, but it has permeability too. It has great permeability too. And actually, when I was examining that road cut, the part, remember the boundary of the Pottsville Formation and the Munchuk Formation, and I said the water was coming out of the shale. Well, shale's not good at storing water. Conglomerate's much better. So what was probably happening is the water was seeping down through the conglomerate, and then it hit the Munchuk shale, and then it was like, all right, time to come out the side, because it didn't want to pass through the shale, because shale is not good for water. Water can pass through shale, but it's not great. So that's conglomerate. And then right here we have the Llewellyn Formation. The Llewellyn Formation, these rocks are at least like 308 million years old. And the Llewellyn Formation is actually the youngest rock layer that's at the surface in Pennsylvania. All the younger, like Jurassic and Permian, whatever, all those rock layers washed away or eroded away. They're in the seashore. They're in the continental shelf somewhere. The Llewellyn Formation is the oldest. The youngest formation that's still at the surface, and it's the formation that had all the beds of anthracite. And you can see in here there is a lot of mica in there. So these sediments were definitely deposited by a river. Mica is micaeous sandstone, shale, whatever. That always means a river. They said mica can't be transported by air. So sandstones that were made by air action don't contain mica. And I wonder why that is. I wonder if mica would just burst into a bunch of pieces, or maybe the air can't pick it up, or I don't know. Even a sandstone made by wind, that would be an interesting sandstone. When the Llewellyn Formation was formed, Pennsylvania was a broad, plain, with a whole bunch of rivers, and then a huge forest grew, and that's where all the plant, that's why the Llewellyn Formation is famous for plant fossils, etc. So that's all I want to talk about today. I am going to examine these rocks further in another video when I do the diagenesis of sandstones. So thank you, and keep watching my channel for more geoscience content, and like and subscribe, and have a great night.